Hey, geometry. Today we're going to do 11.2 areas and sectors. So last time what we did was circumference and um, arc lengths. So a circumference was the whole perimeter outside of the circle. So how long or how much of the circle there is. So it's the line right here. And then the arc length was when you cut it into a small piece like this. It'll be a section here, like a section of the circumference. So area and the sector is very similar. Area is going to be the whole space inside the circle, and sectors are going to be a piece of the area of the circle. So first, let's talk about area. This point is the center, and the line from the center to the edge of the circle is our radius, so I'm going to call that r. To find the area of the circle is this formula. The area equals pi r squared. This is probably not absolutely new to you. You probably definitely at least have seen it in your PSATs. I don't know when you learned this. Maybe 7th grade, 8th grade. You might have learned this before, but I just can't remember. I haven't taught middle school in a long time. But this is the area of a circle, so you got to make sure you know that. So, very basic. Let's do two examples. One where I give you the radius and one I give you the area. Find the area when the radius equals, let's do 10. Okay, so the area equals pi times 10 squared. Remember pi is some number, and we're going to use 3.14 for that. Times, now what's really important is that radius squared, only the radius is squared, not pi. Make sure you know that. Only the radius is squared. So 10 squared is 100. So 3.14 times 100, look, I don't need to pull out the calculator. I could just move the decimal place. So 314. So when we talk about area, if it ever asks for units, it's unit squared, because we're talking about like 2D shapes. So it's like a little 2D. So it's 314 units squared. Could be inches squared, feet squared. Remember, I don't really grade off units. I just want to show that to understand it's slightly different than circumference. Circumference was just straight units or inches or whatever. Let's go to the next one. So what if the area equals 113.04? Find the radius. Well, 113.04 equals pi r squared. So r squared is a variable, and that's raised by the exponent. So before we could do anything, we have to make r squared completely by itself. So I want to divide pi first on both sides. So 3.3113.04 divided by 3.14. Well, it's by design, is a nice clean number, 36 equals r squared. Square root both sides to get rid of the square. 36 square root is 6 equals r. Just a reference, in algebra we talked about is it plus or minus 6, but you can't have a negative length. So in geometry it's just going to be positive 6. So your answer is r is 6 units, and that's units to the 1 power. So that's your basic area and finding it. So that's your formula. Now we're going to get into sectors, which is a piece of the circle. Okay, so I made a really nice circle here. Let's put the center, and let's make what we call a sector. So when I say a sector, I'm saying the space right here. If this was a middle school class, I'd say how much pizza are you getting, or how much pie you're getting, but the sector is the area Well, last time when we talk about the arc length, it's just the line from here to here. When I talk about the sector, I'm talking about the area in here. So how do we find it? Surprisingly, no, maybe not surprising to some of you, it's exactly the same as the question from before, just with a different formula. So it's the same but different. So what do I mean by that? When we found the arc length, we did a proportion. From a piece of the circle to the whole circle equals the piece of the circle to the whole circle. We're going to make that same proportion again. Let's talk about this first. There's still an angle theta, and there's still a radius involved, but there's still an angle theta, and I'm going to imagine that theta's in here, it's just shaded in. So that angle on the inside of the circle is going to represent some percentage. Now remember, it's theta, or, and more likely they're going to use the measurement of AB. Okay. So these are the same thing, the angle on the inside. Over, think about it for 3 seconds, what's a full circle? 360 degrees. So this is part of the circle, how much of the opening is, over how big an opening is a total circle, which is 360, is going to equal part of this sector right here. So we're going to say sector of arc AB. So, or we could say area of sector, it might say, but sector AB over what is the area of a full circle? Well, it's our formula up here, pi r squared. I could say equals A. So area equals pi r squared. So this formula is also super critical, and you want to make sure you have that somewhere. Okay, so we have our ratios. Let's do a couple of examples from it. Okay, we're going to find sector AB from this given information. Now, if this one's 8, it's just very important to know, if this is 8, this radius is also 8. So it doesn't matter which one they tell you is 8. But the radius happens to be 8 from the picture, and the angle happens to be 70 degrees from the picture. I'll give you a second to write that down if you're writing down notes. Now we're looking for sector AB, so that is my variable right there. So I could call that X or whatever you want. So I'm looking for sector AB. Right here, I'm going to need the whole area. To find the whole area, I could do pi times 8 squared. I know the radius is 8, so I could plug in 8 for that. Over, over on the top, the angle. So what's the angle here? Well, that's 70 degrees. So that's 70 degrees out of the total circle, which is 360 degrees. So let's do some simplifying before we do some cross multiplication. So we could write this run as 64 pi. And some people like to have the actual decimal, so we could change that into 200.96. Now, you could use 296 and do all your math. I'm going to use 64 over pi to show maybe a simpler way and then take care of the pi at the end. So I'm going to use 64 over pi, and I'm going to show you how we do that. 70 over 360, they're both divisible by 10, so I could take this out. So it doesn't look like I could reduce it more from 7 and 36. So let's do some math. Again, I'm going to say I'm going to use 64 pi, and I'm going to show you how that works. You're just going to use the normal numbers normally. So 64 times 7. Oh, we're going to do the cross multiplication. So we have 36x equals 7 times 64, which is 448 pi. Then I'm going to divide 36 and divide 36. So x equals 448 divided by 36, seems to be 12 and a third. No, 12 and 4/9. So 12 and 0.4 repeating pi. Oh, it's off the camera, my bad. So we got 12.4 pi. Now, I'm going to be very honest, especially higher level math, or like algebra 2. Sometimes you're just going to write it like this: 12.4 pi, 12.4 repeating pi, or 12 and 4/9 pi. And I'd be satisfied that everyone would be satisfied with that. But since we're practicing with the full decimal, let's give the full decimal. So 12.4 repeating times the 3.14 is 39.075 repeating. So we're going to round that to 2 decimal points. So 39.08. It rounds up, happens. So your sector AB, happens to be 39.08. Okay. Now, if you use 200.96 the whole time, you should get this. You might get your estimation slightly off. You might get like a 0.07. I understand that, and that's okay. You shouldn't get like so off that you're like at 38 though. So if you are using 12.4, you could just put in your calculator 12.44 and then do the math. Again, your estimation shouldn't be so off that you're like at 37 or 38. It should be still something close to that. Okay, so that's your straightforward one where we find the sector. We're going to do one where I'm going to ask you to find, let's say, the radius. I'm going to do one where I find the angle. Okay, so this one, they give us the angle and they give us the area of the sector. The original question asked for area. I'm going to ask for 2 things in this situation. Find me the area, and then find me the radius. Now, it turns out finding the area is easier first, so we're going to find the area first. So why don't we start? Again, we're going to set up our proportion. Then let's do our math. Okay, let's see what we got here. All right, do we know the part of the sector? We do in this case, so just give it right to us. So this is 35. That's a meter squared. So that's just the unit. We don't really need to know that. We don't know what this is here. I'm going to put A for area, okay? I don't know what the area is, so I'm going to put A for area. And then after I find the area, I'll find the radius. But it's a lot easier to think about it as area first and then do the radius second. All right. Do we know how big the part is of the circle? Yep, 40 degrees. Do we know how big the part is of the whole circle? Yeah, 360 degrees. Okay, let's do some simplifications first. These are not able to simplify. Here we got 40 over 360. I could take off the 10s. I could take off the 0. So I got 4 out of 360. And then 4 out of 360 could reduce to 1 over 9. Well, that makes my life a little easier. 35 times 9. So we're going to do cross multiplication. But this is 1, so it's really simple. So it's going to be A equals 35 times 9. 350 minus 35, so 315. Yeah. So the area is 315 meters squared, just because it's meters. Again, I'm not too picky about units. I'm just showing it to be proper. So that's my area of the whole circle. What is the radius, though? Well, we got the area, which is 315. What is the radius, though? Okay, well, we know the formula for area. Area equals pi r squared. So let's find the radius. So 315 equals pi r squared. I'm going to divide by pi first. This should be about 100, but it's not going to be, or about, it's going to be very close to 100, I imagine. So what is this, 315? 315 divided by 3.14. Like I said, it's a really close to 100, 100.32. And when you're doing your calculations, just go to 2 decimal points when you want to round. Because we make pi 2 decimal points, we want to keep that rule consistent. So if this is 2 decimal points and pi is 2 decimal points, we should be rounding to 2 decimal points. So I did 315 divided by 3.14 and got 100.32. Now I got to square root both sides. So radius should be 10. It might be so small it just be rounds to 10, but I don't think so. So let's see. No, square root. So square root of the answer is 10.002. So 10.02. Some fields of mathematics would just write 10. They wouldn't even round to 0.02. But let's be consistent. So this is 10.02 meters squared. Okay? Or no, that's not meters squared. I'm sorry, just meters. So that's the radius. And I'm going to ask a bonus question of this one. We figured out that this sector is 35 right here. This is 35. The question is, what is this section right here? What we would call the major arc. How do we find that easily? Well, we know this is 40 degrees. Maybe we want to do 40 minus 360, which is 320, and do our ratio there. But there's an easier way. I know the sector is 35, and I know the whole area is 315. So I want you to think, what can I do to make it a little easier to find the missing part, which is this. Maybe I'll just leave it white. So how do I find the area of the white section? Well, if you suggested just simply do, you know the whole thing's 315, and I take out that shaded piece right here, the shaded piece, which is, we know is 35, and we could subtract it out, kind of like if you have a piece of the line and you're taking a little piece off, the rest of the line would be. So 315 minus 35, that's going to be 0, and then minus 31 minus 3 is 28. So 280. So this white spot here, which you would call, if there's no letter C, you call the major arc of AB. But 280 would be, and I guess I should just put a C here, would be the sector of arc ACB. Okay? So sometimes it might ask you, hey, you have this little piece, can you find the big piece? So you have two options. You could find the area of the little piece and then subtract the area of the whole thing. Or you could find what is your missing angle. And how did I get I think it was, 45 degrees? No, it was 40 degrees. How did I get 320 degrees? Well, 360 minus 40 degrees, which gave me 320. So notice you're doing the subtraction. You're trying to find the other one by removing the 40 degrees, or you find the other sector by removing the other area. I think, is that everything I want to cover? We did an area. Oh, real quick, I'll do one for if you're looking for the angle. Okay. Here's the last example, and so my video doesn't get too long. It's already too long as is. But, okay. Find the measurement of AB. So we're looking for this theta here, actually. We're looking for this theta right here. But notice I give you sector ACB of C. I'm sorry. The sector of ACB is 150. So what I gave you is the area of the major arc. I didn't give you the area of the minor arc. So this is going to be a multi-step problem. And this is what I'll end it off with. Okay, so find the measurement of AB and find so given this sector. So I want to find the angle here, but since I'm given the bigger area that's kind of shaded in, I'm going to find this angle first, okay? I forgot what lowercase theta is. So we'll just find the other side, okay? So we're going to set up our proportion. Since we're using sector ABC, we want to use that. So what I'm looking for is a measurement of ACB. So we're looking for that. And again, maybe just write X because that'll be easier as a variable. So I'll just change that to X actually. But remember, what I'm going to find is measurement of ACB. Okay? So we got sector ABC. So we're going to put that in 150.72. We have the radius right here, which is 12. So that allows us to find the area, which is pi radius squared, or pi, I can actually plug in the number, 12 squared. And we got this section right here. The whole rotation of the circle is always 360 degrees. Our very consistent friend here. Okay, let's do some math. 12 squared is 144 pi. So 144, so I just wrote it like that. And again, I'm going to use as terms of pi and do the pi at the end. All right. Sadly, there's nothing to simplify, so we're going to get some big numbers, but luckily everyone has a calculator. If not, everyone has Google. So let's do some cross multiplication. So 144 pi x, that's pretty simple. 144 pi x equals 150.72 times 360. It's going to be a really, really large number. And I'll just write it down here. 54259.2. Very important. You could just put this all in your calculator in one shot. There's a danger to that, especially when you do division, because of the order of operations. I remember that was a problem. I think it was in the last test we had, or a test beforehand. So that's why I do step by step. You could put this in one string as your calculator, like if you set it up correctly. But there's a danger to that. So I like to go step by step. So we got 54,259.2. So we're going to divide on both sides 144 pi. Divide on both sides 144 pi. So I'm going to divide both sides. And then to find 144 pi, you put it in your calculator. But I'm just going to divide it like that. So divided by 144 pi, or 144 and 314. So I get x equals 120. Okay, so this is 120 degrees. So x equals 120 degrees. So measurement of the large arc ACB is 120 degrees. And I guess looking at this, I drew my picture wrong, so let me redraw it a little bit. So I guess it would actually look more like this. So I made a little mistake there. This is the smaller one. So it's, it kind of sucks, but we actually found this, which is a smaller one versus the bigger one. Because think about this, half of the circle is 180. So if it's bigger than 180, you know it's a larger arc. If it's less than 180, it's a smaller arc. So I messed up the question here. I got you the smaller piece. So let's say I want to find this one. How can I find this real quickly? Well, if I know this is 120 degrees, to find this angle, I just do my whole circle, which is 360 degrees, minus the angle I just found, which is 120, which is going to be 240. So if we kept with the original question, it's 240 degrees. The only issue I had here that I made as a mistake as the teacher is just that I drew it wrong. But relatively, the process is the same. I could have even left it as a word problem. So again, I apologize for such a long video. I just want to go over more examples. And I just want you guys to have a wonderful day.